So in this video we're going to actually build a Discone antenna for 2.4 gigahertz. Now the Discone antenna is an antenna that I wanted to build for quite some time, but unfortunately the online calculators that you use to build one of these, the measurements don't actually match up to 2.4 gigahertz. And for some time I played around with building one of these and I could never quite get it right. Now it was only when I actually got my network analyzer that I was able to go back and look at this antenna and start building one from scratch, not using any online calculators. And the measurements that I came up with were totally way out to what the online calculators were giving me. So that's been my problem all along. Now the Discone antenna, when it comes to the ham radio people, is extremely popular. It's relatively cheap and it gives out good omnidirectional gain, and you can get quite a bit of different distance with one of these. And we always look at directional antennas when it comes to 2.4 gigahertz, but sometimes you just want a really good omnidirectional antenna. And today I'm going to show you how to build one of these, and one of these is extremely powerful, and you can compare it to a cloverleaf antenna. It gives out the same kind of performance as a cloverleaf, but it's quite simple to make, and I'll show you how to do it. One of the main resources you're going to need to actually build this antenna is to get yourself some tin. Now it needs to be tin so you can actually solder to it. You can't use aluminium, but old biscuit tins, sweet tins, things like that, a really good resource for tin. Don't go buying any, just recycle. So like I said, we're going to use a piece of tin from an old sweet tin, biscuit tin, etc. And what I've done is I've cut this out, and I've also tried to get rid of some of the paint as well to make it a lot easier to solder to, and also we'll get a better finish at the end as well. It'll be a lot easier to get rid of that paint now than it will be at the end when we constructed it. And also this is one that I've made out of a piece of copper. Now copper is a lot easier to work with. It's a little bit softer than this tin, but copper is a lot more expensive, and there's no difference between the two when you're testing the finished antenna. So unless you've got some copper lying around, I wouldn't buy it just to make this antenna. Use some recycled tin from a biscuit tin. So I've just stuck the templates down on here with a little bit of spray mount. You can use a Pritt stick, glue stick type of thing if you like. Just something to hold them down while we cut it out. Now this tin is thin enough to cut out with some heavy duty scissors. You don't particularly need tin snips for something that's this thin, but you want to get around that line as close as possible, and just take your time and be careful you don't cut yourself. So these are the two cut out now, and what I'm going to do before I remove the template off the metal is drill a small hole through the centre of this circle here in order to attach the centre connector of the coax to this, which will be our driven element part of this antenna. Just get a much better connection if you drill a small hole through here and then tin onto it as you would if you were soldering a component onto a PCB board. So I've got them both cleaned up now, got rid of any traces of glue from the spray mount, etc. from when we put the template on, and we've got a nice hole straight through the middle of this circle here. Now what I've gone ahead and done, I've just got a little bit of emery paper and just buffed up the sides of this triangle shape here, and I'm going to add a little bit of tin down the sides because that's where we're going to bring it together to form the cone and join it on. If I put some solder on here now as a tin, then it'll make the job a lot easier. Now normally for most of my electronic projects I use lead-free solder. I know a lot of people don't like it, but because it's been banned in UK schools for well over 10 years now, it's just what I'm used to, and once you get used to it it's not too bad. But for this I'm going to actually use lead-based solder tinning two pieces of metal together like this, it's a lot easier using lead-based solder than it is lead-free solder. So a little bit of lead solder. Just warm up the metal first. Just keep adding a little bit of solder and let it flow. And the same on the other side. Once you get the metal heated up, you can almost paint it on. So to actually start making the cone, I find it much easier if you get yourself some thick rag like this. This is an old towel, so it's quite spongy, and use your thumbs to gently bend the tin around into a curve shape. Keep applying pressure. To get it as smooth as possible. Once you get it like that, what you can do is bring the two sides together, and then we can hold them with a little bit of masking tape while we actually solder on the inside. So what I'm going to do is put a bit of solder on my iron there, and I'm going to solder the end up here first and then work at the back and hopefully bring it together. If I try and solder it all at once, what it'll do, it'll expand and pull itself apart. So start here first, and then work from the top and bring it out to the edge. So now we've got a nice neat joint, and I'm just going to let that cool down and then work on it a little bit more to get more of that cone shape. So again, I'm just using the towel again and my thumb. I'm just getting it nice and round. And you see here, I've got a little bit of a lip here, so what I'm going to do is just trim that off with a pair of scissors, and then I'm going to hold it down flat on some sandpaper and just give all that base a sand, just to get it nice and levelled off, and also to remove any edges that are a bit sharp and you might end up cutting yourself, so just to finish it off. So not too much, just enough to actually blunt the edges so you're not going to cut yourself, because this angle here, the length down here, is actually the wavelength we're looking for. So if you actually sand away too much, then you're going to destroy that wavelength. So just be careful. It's just enough to take off any little blunt edges that might end up cutting yourself on, just to finish it off. So what we need to do now is actually drill a hole through the top of this in order to fit the center conductor of the coax cable through, so we can then solder on to the top part of the antenna. And remember that these two need to be isolated from each other. So the easiest way to drill a hole through the top of this is to turn it upside down, try and find something like I've got my solder reel here to hold it in place, and then drill directly down through there. So we've got a hole straight through the top and just tidy up this little piece of metal here. So now we're going to look at connecting the SMA connector to the antenna. Now here's one that I finished, and what I've got here, I've got a piece of metal tubing which I've actually got off a net curtain rail, and I'm using that as the center connector, if you like. And it because it's rigid, it's nice and strong. It'll stay up straight when it's connected to the alpha card itself, or whatever you want to connect it to. And here's one that I haven't put a metal shim on, and as you can see, it's still flexible, stays up okay. One of the main reasons I didn't use this on this one is because at first I thought what this metal shim might do is affect the impedance of the LMR cable, but when testing it on my network analyzer, it actually doesn't do that. So you're safe to use something rigid like this. So what I'm actually going to do, I'm going to crimp on my SMA connector to this short piece of LMR cable, and this is just the correct diameter so I can feed my LMR cable up. And instead of using this crimping shim here that came with the kit, I can actually crimp directly onto this metal piece of tubing here, like I have on this one. But if you don't have crimping tools, etc., you don't want to do that, then one of these cables you can get off eBay, and this has got the two female connectors on either end, so we can cut that in half, and we can use this one, and you can put that up inside the tubing itself and fix it with a little bit of hot glue at the bottom there so it doesn't move around. So then you've got a nice rigid connector there, so you can connect it into whatever you like. So here is the SMA cable now, and it's crimped on here. So this is going to be the body, what we're going to solder to the inside of the cone here. So I've put some tin around the edge here so we can solder directly onto the cone, and I've also packed in the outer sheath of the coax in there so it makes good contact, and also soldered it in, put a little bit of solder in there to hold it in place. It's a very similar technique to I've shown you before on making simple dipole antennas for different projects. It's very similar. So that's finished now, and it's in there. It's nice and solid. It's not going to go anywhere, so it doesn't need any hot glue or anything like that. So now we're going to actually look at attaching the disc part of this antenna now, and we're going to cut back some of this insulator and attach this to the top. So before we actually fit the disc onto this antenna, what I've made here is a little plastic washer, and I've made it from a pen top, and you don't want it to be thicker than 5mm. The distance from the disc to the cone, if it's greater than 5mm, it starts affecting the SWR of the antenna, and the SWR will start to go up. But if you keep it at 5mm and just under, this is actually I've sanded it down on a flat piece of sandpaper like so, and I've got it down to 4mm. Then the SWR is matched. It's at 1.1 I believe, but any higher then that SWR starts to go up. So I've made this little plastic washer, and what I'm going to do is epoxy it onto here to give us a nice level base to then fit the disc onto. But on the first ones that I built, I actually used some hot glue, which is under there. It's a little bit more messier, but you can't really see it once it's together and painted, but it's not quite as solid as I'd like. So I've decided to go with the little plastic washer rather than hot glue. Epoxy putty as well would be probably strong enough to put under there to keep them apart, but I'm going to see how this works out. So now that the epoxy is set on this plastic spacer, I've gone ahead and tinned up the centre connector and cut it down slightly, and I've also put a little bit of tin on the disc as well. So now what I'm going to do, I'm going to solder those two in place, and hopefully it should sit nicely on top of that plastic spacer. So here is the antenna, and I've just put some paint on it to tidy it up a little bit. But before we actually go ahead and see how it performs next to a rubber duck antenna, I want to show you these two antennas that I've made exactly the same way, but the difference is I've changed the angle of the cone. Now this antenna is like two donuts on top of each other. You've got a bigger ring donut here at the base, and then a smaller ring donut here on the top, and by changing the angle of the cone, I've squished those two donuts together. And one of the reasons I wanted to actually build this antenna is because although it's a omnidirectional antenna, it works in a 360 degree space, if you like. It's because you can actually change the angle of the cone, you can also get some of the properties that you would normally get from a directional antenna. So by squishing the cone like this, you are getting better signal over distance on a signal that's far away, if you like, but it will not pick up so well some of the signals that are around it. So you can also, like this one, now this one is a much steeper angle to the cone, and this one will not work as well over a greater distance, but what it will do is pick up more signals that are more local to it. So it really depends what kind of application you want to do with this. And if we take a look at the template here, if you look at this second circle, I've actually drawn some angles here, so you can actually cut them out and you can actually design your antenna whichever cone you would prefer. But this one that I showed you how to build, this is probably best of both worlds. It gives you a nice omnidirectional signal in all directions, and also gives you quite a bit of decent range as well for something that's so small. So at the moment I've got this stock rubber duck antenna connected to the alpha card, and I'm just moving it around a little bit, trying to get a slightly better signal. It's hovering around 55%. Seems to be staying around there. So what I'll do, I'll disconnect this and connect the Discone antenna in and see what happens. Straight away it's jumped up 80%. And that buzzing you can hear is it's seeing more access points now it's got this antenna on. Seems to have levelled off just over 80%, 82%, so performs much better than a standard rubber duck antenna, so I'm pleased with that. It's still picking up access points, you can hear. So nice strong signal. So I hope you enjoyed that. If you did, please give it a big thumbs up, and remember to subscribe if you want to see more videos like this. And if you've got any questions or anything you feel that you could add to improve this, then please by all means drop a comment below, and I'll catch you for the next one.